In a polynomial function, we must know the behavior of the graph, depending on the leading term. For example, if the leading term even has an even degree, and if the leading term is positive, it will start from infinite and it would live in infinite. And if the degree is odd but the leading coefficient is positive, it will start from minus infinite and it will end at infinite. If we have an even degree and a negative leading coefficient, it will come from minus infinite and it will live in the minus infinite. If we have an odd degree and a negative leading coefficient, it will start from infinite and it will end from minus infinite. Let's see an example. We have a polynomial function. As we can see, it is negative. It has a negative. It is negative. The leading coefficient is negative, and the degree is an even degree. So the behavior is like this. It starts from from minus infinite and it will live at minus infinite. First we factorize, it is equal to, and as we factorize, it will give you like minus x squared times x plus 5 times x minus 2. With that, we are going to find the x-intercepts by equating the factors to 0. This is a factor, x minus x squared is a factor, x plus 5 is a factor, and x minus 2 is a factor. So first we must find the x-intercepts. And is equal to minus x squared is equal to 0, thus x, the first x is equal to 0. Then x plus 5 is equal to 0, so x is equal to minus 5, and x minus 2 is equal to 0, thus x, the third x is equal to 2. Then we must take as note that we have a multiplicity. There is the degree. A multiplicity is equal as the degree. For example, the first here the degree of x squared from 0 is equal to 2 because we get it from like minus x squared, so the multiplicity is 2. We take it from there. Then we here x plus 5, it has a multiplicity of 1 because it doesn't have like it is not the squared or cubic or something like that, so it is 1. It has a multiplicity like that, 1. And x minus 2, it has a multiplicity of 1. It has degree 1, it has degree 1, it has degree 2. And then the degree is even here, so in the graph the behavior is that in that value, in the 0 value, it will bounce in the x-axis, and it will have odd degree. It will cross the x-axis, and that's all. And here we have the graph, the final graph. As we see, as I said, it starts from minus infinite and it ends at minus infinite. It crosses because the minus 5 has a multiplicity or degree of 1 that is odd. It crosses. The 0 that has a multiplicity or degree of 2, it bounces in the x-axis, and it crosses in the 2 value because it is odd. And this is the behavior. Another example with an even degree, no, with an odd degree as a leading term and positive leading term. First, we must factorize, as I said. It will give you like cubic x times x minus 1 squared, or you can leave it like cubic x times x minus 1 times x minus 1, but the leading term will be the same. But it would be more effective if we wrote it like this. So first, what we need to first, and then we find the x-intercepts, equating the x values or the factors to 0. So it has it is even. Here the 0 is odd, and this is even. And it has a multiplicity and even multiplicity. So first, this multiplicity, the multiplicity of the 0 is equal to 3 because here is cubic x, and here the multiplicity is 2 because we have x minus 1 squared, so it is even. So as I said, if it is odd, it bounces, no, it crosses, sorry, and it is even, it bounces, and the graph would be more or less like this. And why does it crosses like in the 0 value? Because we don't have another value, so here the 0, it is like x cubic x, it crosses the 0 value. Here we are, x is equal to 0, it crosses here because it is odd, then it bounces in the first value. It bounces because it has an even multiplicity. That's all for